hello from Ireland. Not really. Obviously, I'm doing this before I left. So you have this notes. 13.1 is actually the easiest section of the chapter, which is why I saved it for when I wasn't going to be here. So symbols, this is like an upside down U. It means intersection. In other words, elements that belong to both sets. And I'll talk about what we're talking about with sets in a second. Union is all of the elements in each set, the total amount of elements. So I'm going to call this circle set A and this circle set B. It's a set of something. Maybe it's a set of numbers, maybe it's a set of letters, maybe it's a set of pizza topping options. The intersection only includes elements that are in both sets. This is stuff that's only in A, and this is stuff that's only in B. This would be stuff that's in A and B. For example, I might talk about set A is pizza toppings, and set B is things that go in sandwiches or on sandwiches. Something that might be in set B that wouldn't be in set A would be lettuce. I would put that on a sandwich, but probably not on a pizza. Something that might be in the intersection would be pepperoni. Maybe you put pepperoni on your pizza and you like pepperoni on your sandwiches. Okay, so that's an example. Union is just all the stuff. Here's set A, here's set B. Union is all the stuff. Okay? Excuse me. So mathematically, if I have a set A that consists of just the numbers 1, 3, 5, and 8, set B is just the numbers 3, 5, and 7. This is asking for the intersection. So that's just something you're going to have to memorize, that the upside down U means intersection. And that's the stuff that's in both A and B. So if you look here, A has a 3 and also so does B. A has a 5 and so does B. This is only in A. This is only in B. This is, excuse me. Rewind. This is only in A. This is only in A. This is only in B. I want the things that are in both. So the intersection is 3, 5, and we put it in the squirrely looking brackets because it's called a set. The union is all the stuff, and we don't repeat. So all the stuff here, I'm going to list 1, 3, 5, 7, 8, and it's just nice to list them in numeric order. So you'll see I've got all the elements from A, 1, 3, 5, 8. I've got all the elements of B, 3, 5, 7, without repeating. Subsets are little mini sets of all the stuff in a bigger set. So maybe I'm talking about ice cream flavors, and I want to know all the possibilities for subsets of ice cream. So first, we're always going to include what's called the empty set, meaning I don't want ice cream. I'm a weirdo. And then we have the set that just includes vanilla. I only like one flavor. I don't like my flavors of ice cream touching or together. I only like one at a time. Chocolate. I only want chocolate. I only want strawberry. Then there are sets that include 2 flavors. So let's be consistent in having a pattern here. So we're going to say, okay, what if I have vanilla and strawberry? That's one way to do 2 flavors. Or I could do, I don't know why I did vanilla and strawberry. I'm not being consistent in a pattern. Vanilla and chocolate was what I meant to do first, so let's do that next. Vanilla and chocolate. So I've got vanilla chocolate, vanilla strawberry, but I don't have chocolate strawberry. Excuse me. And just like we talked about before break, if I went up to an ice cream shop and I said, I want a vanilla and strawberry bowl of ice cream, and then like 2 minutes later I go back and I say, oh shoot, can you change it to a strawberry and vanilla bowl of ice cream? They're going to look at me like I'm bonkers, right? So we don't care about the order here. So there's just these ways to combine into making 2. And then of course there's the actual set itself. of all 3 flavors because I really like ice cream. So then you're like, oh, do I have to list all this out every time? No, there's an easier way to find the total number of subsets. So here I can see 1, 2, 3. There were 3 items in my original set. 1, 2, 3, 4, 5, 6, 7, 8 subsets, right? Just counting those. There's this counting formula that tells me how many subsets there are. And this is just something you have to memorize. I don't have any easier thing for you. So this is it in words. I'll just do some examples, okay? 100 college students were surveyed. This is the total number of students. 37 were in Math 101. So this I'm going to call my set A, being in Math 101. 60 were in Math 114. I'm going to call this my set B. That's a different class, so that's a different set of students. 17 were in both. So this was both. So take like 2 seconds to talk to your neighbor. What is that representing that they were in both? So that's representing the intersection. They were in both of the classes. So I'm going to put the 17 right here. That is for being in both Math 101 and Math 114. The number of students in set A was 37. 37 students, right? The number of students in set B was 60. How many students are registered in Math 101 or Math 114? So this represents the number of students in A union B. The or means all of the stuff, okay? So we're going to just use the formula. The number of students in A union B, I'm just copying this formula right here. And then plugging the numbers in. So number of students in A union B is going to be number in A, 37. Number in B, 60. Number in the intersection, 17. And then we're going to obviously just do the math on that. That's 80. So there were 80 students in Math 101 or Math 114. How many registered for neither course? Okay, well, we already used this formula, so it's not going to be that formula. Take a second and see if you can figure out something that we haven't used that can help us answer B. Okay, so we know the total number of students is 100. And we know that there are 80 students that are in any class, whether it be one or the other or both. That's the total number of students in anything. So that means 20 students not registered. In either class. All right, okay, let's flip. We kind of already did this a little bit before break. Number of possible combinations. Excuse me. The number available of the first choice, second choice, etc. We multiply all of those together. So at the Tyson Grill, a prefix dinner gives you the following choices. You can get super salad for your starter. You can get chicken, beef, pork, veggie, or pasta for your entree. You can get a pastry or ice cream for your dessert. And we want to know the total possible ways to order a dinner, basically. So I'm going to go, my first choice is the starter. How many choices do I have for the starter? I have 2. My second choice I have to make is the entree. 1, 2, 3, 4, 5 choices. And my last choice I have to make is the dessert. And I have 2 choices. I just multiply those together. 10 times 2. I have 20 options for my meal. And we could sit here and list all of them out. It would be very tedious. We would go soup, chicken, pastry, soup, beef, pastry, soup, pork, pastry, soup, veggie, pastry, soup, pasta, pastry, salad, chicken, pastry, salad, beef, pastry. That would get long and tedious, but we would see that there's 20 options there. All right, have fun working on your homework, and I will see you tomorrow.